All right, so we left off on example number 1, and I was just saying that if we find p of x and say that p of x has an infinite number of terms, like I showed the first 4 terms and then I showed the nth term, but I'm showing that this could continue on. If I never stop adding terms to p of x, then p of x would match e of x, e to the x exactly. We don't usually have an unlimited number of terms, though. A lot of times we're just approximating. So they might tell you how many terms or how many derivatives or what degree they want your polynomial to go to. So this notation right here is called fourth order, which also means get to the fourth derivative. But it doesn't necessarily mean 4 terms, and it doesn't necessarily mean that your answer will be to the 4th power, because sometimes derivatives evaluated at the center give you like a value of 0, and so sometimes some terms will go away. So we'll get to that a little bit later, but this P4 means, okay, I want to approximate the natural log of x, and I want to use a 4th order polynomial to do that. So this will just be an approximation. The first thing I do is always the same way I set up all of these problems. I start by rewriting the function for myself. F of x is natural log of x, because remember, the constant term of your polynomial will be f evaluated at the center. Now, we're centered at c equals 1. So instead of plugging in 0 like I did for a Maclaurin polynomial, this is now a Taylor polynomial, which is just a more general Maclaurin. And our center is 1. So I need to find f of 1, not f of 0. Can't find f of 0 anyway, right? Because natural log of 0 is undefined. Anyway, what is natural log of 1? Natural log of 1, e to what power is 1? Equal to 0. So there's no constant term for my first term of my polynomial. We need to take 4 derivatives. So we need to get f prime, we need to get second derivative, we need to get the third derivative, and the 4th derivative. And then we'll evaluate each of those at 1. What's the derivative of natural log of x? 1 over x. What is the derivative evaluated at 1? 1 over 1 is 1. What's the derivative of 1 over x? Remember, this is like having x to the negative 1. We've been in integration mode for so long, derivatives can kind of make us go backwards here. So remember, that would be negative 1 times x to the negative 2, or negative 1 over x squared. And when you plug in 1 into negative 1 over x squared, you get negative 1. Now, don't just assume that you know the rest of the numbers. It's not going to be 1, negative 1, 1, negative 1. You take another derivative. Remember, this is right now, this is negative x to the negative 2. This would become 2 over x to the third. So here, the third derivative evaluated at 1 is 2 over 1, which is 2. And finally, the 4th derivative, okay, so remember, this is 2, x to the negative 3. So this is going to be negative 6, x to the negative 4th, or over x to the 4th. The 4th derivative evaluated at 1 is negative 6. Now remember, these numbers are just the coefficients for the numerator of what goes in front of each x term. So let's build the polynomial. So what we're saying is the natural log of x is approximated by the 4th order polynomial of x. 4th order polynomial of x, I think I might write it down here because I like to have natural log of x is approximately. So technically there's a 0 to start. I'm going to write that in for our notes. We can always simplify these things. Like I don't normally write the 1 times the previous problem. Anyway, it's 0 plus, now the next coefficient is 1. It's not just times x, it's times x minus c. So x minus 1 to the first power, technically over 1 factorial. The next term has a coefficient of minus 1, so I'm going to write minus 1. Then it should be x minus 2 squared over 2 factorial. The next term has a 2, so plus 2, x minus 2 No, sorry, not 2. X minus 1 squared for the previous one, x minus 1 cubed for this one, over 3 factorial. And I'm going to squeeze in my last term. It says -6. So minus 6 times x minus 1 to the 4th over 4 factorial. And I stop there. I don't write a plus ... because this is only a 4th order polynomial. I want to simplify things a little bit. Natural log x is really just, let's get rid of that 0. Let's not write the 1 factorial. So it's x minus 1. Don't need the 1 right there. Minus x minus 1 squared over 2 factorial is just 2. What about what's going on here? 2 over 3 factorial. Remember, 3 factorial is 3 times 2 times 1. 2's cancel. So you really have plus x minus 1 cubed over just 3, right? Or think of it as 2 over 6 reduces to 3, 1/3. Same thing here. 4 factorial is 4 times 3 times 2 times 1. 3 times 2 cancels with 6. So it's really just minus x minus 1 to the 4th over 4. Now, natural log of x, we are going to eventually memorize the Taylor polynomial, or the Maclaurin polynomial, I should say, for natural log of x, but I just wanted to show you. It's got this nice pattern. Let's do one more comparison. Let's put in natural log of x and type in what we have here. So that was x minus 1 minus x minus 1 excuse me, squared divided by 2 plus x minus 1 to the 3rd divided by 3. And then it was minus x minus 1 to the 4th divided by 4. Now remember, 1 is the point of tangency. So these should be very similar around 1 and close to 1. And then you can see as you head out, they stray off. If I did one more term, this would head up and capture a few more values of natural log x before it gets off. All right, so again, they're pretty close for a little while. Find the 5th order Maclaurin series for f of x equals sine x. Maclaurin tells me that c is 0. So instead of having x minus something squared, I'll just have x squared. 5th order means find p sub 5 of x, or 5 derivatives. It doesn't necessarily mean that I'm going to get an x to the 5th. It doesn't mean that I'll have 5 terms. We'll just have to see what happens. So let's start off this way. F of x is sine x. And what's f of 0? Because 0 is the center. Sine of 0 is 0. F prime of x, first derivative, is cosine x. What is the cosine of 0? 1. Second derivative. Derivative of cosine is negative sine. Negative sine of 0 is still 0. Third derivative. Derivative of negative sine is negative cosine. The third derivative, so negative cosine of 0 is negative 1. Fourth derivative. Something to know about sine and cosine, it takes 4 derivatives to get back to the original equation. The derivative of negative cosine of x is positive sine x. So the 4th derivative will always be equal to the original function. That's kind of just a handy thing to know, I think. Comes into play every now and then. Sine of 0 is 0, and we're supposed to get to the 5th order, so take one more derivative. Get you back to cosine. The cosine of 0 is 1. Okay, let's build our series. So sine x is approximated by this 5th order polynomial, p sub 5 of x. Okay, so sine of x is approximately, the constant term is 0. I'm going to write it unsimplified first, 0. And then we have plus 1 times x, because center zeros, times x, technically divided by 1 factorial, plus 0 times x squared over 2 factorial. Again, I'm just writing this until we get used to it. Minus 1 times x to the third over 3 factorial. And then where are we? Fourth is plus 0 times x to the fourth over 4 factorial. Finally, plus 1 times x to the fifth over 5 factorial. Let's simplify that. Sine x is approximately, okay, so this is just x minus x cubed over 3 factorial plus x to the fifth over 5 factorial. That's our approximation for sine x. Now, in interest of length of this video, coupled with there's a part 1 earlier, I'm not going to type this in, but you can pause this if you want and graph sine x and graph these 3 terms and see how closely they match up. They should be the exact same value at the center, or the point of tangency, which is 0. On the AP test, you'll see this terminology: order, degree, number of terms. So we have a difference between all of these things. Let's just take a look at that last example. What was the order of that Maclaurin series? It was a 5th order. What's the degree of the polynomial? The degree is the highest exponent, which in this one also happened to be 5. So highest exponent 5, so degree 5. How many terms did it have? Just because it's 5th order and 5th degree does not mean we have 5 terms. We have how many non-zero terms? We have 1, 2, 3 terms. All right, so just make sure that you know the difference. Order and degree often match up, but not always. So just be careful. All right, find the Taylor polynomial, 4th order, for f of x that's supposed to be equals cosine x, centered at pi over 3. Right, so that's our C. It's a Taylor, not a Maclaurin, because Maclaurin is C equals 0. So f of x is cosine x, and constant will be f of pi over 3. Cosine of pi over 3 is 1/2. First derivative of cosine is negative sine. Negative sine of pi over 3 is negative radical 3 over 2. Derivative of negative sine is negative cosine. Negative cosine of pi over 3 is negative 1/2. Third derivative is positive sine. Oops. Sorry, my tick marks aren't matching up. Third derivative of that pi over 3. So sine of pi over 3 is positive radical 3 over 2. And finally, 4th order, so 4 derivatives. Remember, 4 derivatives should get you back to the original equation. Derivative of sine is cosine, which is where we started, so that's a good sign. And so the cosine of pi over 3, we're back to positive 1/2. So cosine of x is approximately equal to P4, but I'm going to get straight into the terms. 1/2 minus radical 3 times x minus pi over 3, x minus the center, over 2. And don't forget this part. There would technically be a 1 factorial under there. I write that because it's easy to forget when your a is a fraction. It's easy to forget that there should be a factorial down there. Doesn't matter for 1, but it matters for the rest of the terms. Okay, second derivative. So minus 1 times x minus pi over 3 squared over 2, because 1/2, also times 2 factorial. So now it matters to have the factorial. Plus radical 3 times x minus pi over 3 cubed over 2 times 3 factorial. And I'm almost out of room. 1 times x minus pi over 3 to the 4th over 2 times 4 factorial. You are never required to simplify these. This doesn't actually simplify really, besides maybe taking the ones out. But you would never need to multiply the denominators through unless you're just searching for your answer in multiple choice. All right. Use your answer in part B to approximate cosine of 1. Now, and then part C says evaluate with a calculator. So part B is just saying, let's just write out what you would do because I don't want to write out the whole thing. What are we asking you to do? We're asking you to plug in 1 for x. In other words, we're asking you to find P4 of 1. Now, on my calculator, okay, how do I do that? There are probably lots of ways that you could go through and do this. I would just say, I mean, you could type the whole thing in. You could maybe factor a bit of it out, right? Factor out like a 1/2. And then get 1 minus radical 3 times 1 minus pi over 3. I think I'm going to go that route. Just don't forget that you have factorials over here. You could put it into y equals. I don't know the fastest way, but I'm going to say, I'm going to factor out a 1/2 and just be very careful about it. So factor out a 1/2 from there, I get 1 minus square root of 3 times, actually, let me, there is a nice trick here. I don't want to keep typing 1 minus pi over 3. I also don't, 1 minus pi over 3 is 2 pi over 3. I don't want to have to type that. You can say 1 minus pi over 3 is this. Store that, store is next to 1, as x. All right, so now on my home screen, I'm going to say, okay, 0.5 times 1 minus radical 3. What I mean here is x minus pi over 3, but remember, I stored that value as x, so x. And then, I do need to see my work. Oh, goodness. Crashing my computer, no big deal. Okay, here we go. So I've got this part of it, and then it's minus 1 x squared over 2 factorial. So I'm just going to write minus, not the 1, x squared divided by, what's 2 factorial? 2. Okay, and then it's plus square root of 3 times x to the 3rd. Remember, x is this number stored here, so that's why I'm writing x's. Divided by, what's that term? That's got a 3 factorial. 3 factorial is just 6, so I'm just going to get 6. Plus x to the 4th. It understands x to be in parentheses, by the way, so when I raise it to the 4th, that'll be positive. Divided by 4 factorial is 24. So this is what the Taylor polynomial approximates cosine of 1 to be. Cosine of 1 is about equal to 0. I'm going to write this down. Try to split screen. 0.540. I'm going to write the whole thing. 3023042. What does the calculator say cosine of 1 is? In radian mode, cosine of 1 radian. Awfully close, right? The only two numbers that are different are the last two, so that's kind of cool. Cosine of 1 is about 0.540302305.9. So they only disagree. They agree to 1, 2, 3, 4, 5, 6, 7, 8 places, and they're off by 2 values. So what's the difference? What's our error of our approximation minus our cosine? So I grab those numbers. The approximation minus what the calculator says the value is. Not too far off, right? Negative, so it's 0.1234567 negative technically 17. Those are awfully close, right? accurate to 8 places. So it's pretty amazing that just 1, 2, 3, 4, 5 terms of the polynomial can approximate cosine to 8 places with accuracy. That's pretty cool. That error, that difference, is something that we're going to be looking at in the next couple of days. All right, so that finishes day 1.